The rate of fluid flow within a vessel can be measured using the induced EMF when the fluid contains charged ions. A small magnet and sensitive voltmeter calibrated to measure speed are used. This can be applied to measure the flow of blood which contains iron in its solution in the human body. If the diameter of a particular artery is 2 millimeters, the strength of the magnetic field applied is 0.1 Tesla and the measured EMF is 0.1 millivolts. What is the speed of the flow of blood within the artery? All right, so on our diagram on the next page, we have this setup. So this is what is actually done. A magnetic field is applied to the human body, and we have electrodes to measure the induced voltage on either side of an artery, and we have blood flow coming through. Now the reason this works is if we look at the cross-section of the artery, like that, there are blood cells passing through this, and at any one time, that represents a long conductor, the blood cells passing through. So obviously there's more blood cells around. Okay, but at any one time, those blood cells, they form a vertical line. They are basically a long conductor. Okay, there's iron in the blood, and so we can use that as a as a measure. Well, we can use this to calculate speed.
In surgeries.
Yep. Yeah, this is how they use. This is how you can calculate. Well, this is non-invasive. You can calculate the speed of the blood going through someone's body without cutting them open using this setup. All right. So let's have a look at this. E equals LVB. Now, what are we trying to find here? Velocity. We want the speed. Okay, it's equal to epsilon on LB. Okay, so our induced EMF was what on the previous page? 10 millivolts. 0.1 millivolts. So be careful. 0.1 millivolts. All right. Now the length of our conductor, so the length of this is 2 millimeters. So 2 times 10 to the negative 3, or 0.002. And our magnetic field was 0.1, I think? 0.1 Tesla. Okay. Let's work this out. 0.5. 0.5 meters per second. So it's reasonably, that makes sense. You'd expect your blood would move through your body at about half a meter a second. That's reasonable. All right, passes the common sense test. All right, so the hardest problem, the hardest thing with a problem like this is recognizing what the conductor is. In this case, it's sort of that vertical, that vertical chain of blood cells passing through. Okay, but once you've got that, the maths should be fairly straightforward.